Okay, now we are going to talk about sine and cosine functions and just do a couple of examples on how to plot these two functions. But before I get to those, we are going to define a sinusoidal relation as one which has a graph which looks like a sine curve, okay? Not exactly like a sine, graph, something like a sine graph. Now, one of the main properties of these graphs is that they are periodic. They look periodic, okay? And they can be represented as a simple sine or a transformed sine and cosine or a combination of sine and cosine together. Now, to just give you an example is when you take physics in grade 12 or even in university, you will have occasions that in the lab you are going to have the graph of, let's say, voltage or current, and what you are going to see is that you are going to see a graph which looks like this one, which there is no way you can assume that this is a sine function. But the interesting part about it is that this, first of all, is a periodic function, and it looks like a sine function. And it can be presented with a sine function. With some modification and some transformation, I can get something which looks like this. And then I can represent the current or the voltage using sine or cosine or a combination of these two functions. So again, the whole point is that it is not necessarily has to be exactly like a sine, but as long as it's periodic and it looks like a sine or cosine, you are guaranteed that you can represent it using, as I said, some combination of sine and cosine. And the next paragraph is what I just repeated, is that you can use the combination, which we are not going to cover in this course. Even in advanced function, you are not going to cover those. Hopefully when you go to university, you will see that you are going to combine sine and cosine to represent functions like this one. So, other patterns can be modeled using combinations of two or more sine and cosine functions or transformations of these functions. Now, I'm going to give you a few minutes. I'm not going to take 10, 15 minutes to do it, just to plot the graph of sine x. Now, what I want you to do is that on your notebook, I want you to make a table of values for these values, 0, 30, 45, 60, 90, and so forth until 360, in an interval of 30 degrees, and then, for 45, interval of 15 degrees. Okay? So, give me the exact ratio, which you learned in previous unit, using the unit circle, or the pattern which I gave you, square root of 0 over 2, square root of 1 over 2, and so forth, okay? To write the exact ratio of each of these angles, and then use your calculator to find the decimal value. So, just a few minutes, and then I'm going to do it, here too. Okay, to plot this one, I'm going to complete the table. I know when x is 0, sine of 0 is 0, so the exact ratio is 0, the decimal is 0. For 30 degrees, I know the pattern. For 30, the sine is 1 over 2, the decimal is 0.5. For 45, the sine is square root of 2 over 2, the decimal is 0.171. For 60 degrees, the sine is square root of 3 over 2, which is 0.87. And finally, for sine 90, the angle 90, the sine is 1, and the decimal is 1. Now, going above 90, I'm going to use the unit circle. Just for 120, I'm going to show you is that 120, I'm going to draw, if you don't remember this one, the unit circle. then 120 is going to be 30 degrees here and then 90 here, so this is 120. Now, if you look at this one is 60 degrees here because the whole thing is, 60 degrees, the whole thing is 180, so this means the reference angle, the reference angle is 60 degrees, and I know that sine of 60 degrees is square root of 3/2, but sine is positive in the second quadrant too because sine is the y coordinate. So this means that 120 has the same value as sine 60, which is square root of 3/2, which is 0.87. Now I continue the same way and I come up with this table of values. I just assume you can use your calculator. The only thing is that you have to know all these exact ratios. So you can't use the calculator for these. Now, to plot these, I'm going to divide the x-axis. It's already been given 90, so I'm going to divide it in 30 degrees units, so 30, 60, 90, 120, and so forth to 360. And I'm going to pick 4 boxes to represent 1 unit on y, and -1 is going to be off the chart, which I have shown here with the dot. Now, it's just a matter of picking the points and then plotting approximately the location of the point. So for 0, 0, it is obvious that the point is here, which is the origin. For the point 30 degrees and half, which is 0.5, this one is 30 degrees, so I go up, and half is here, which is the middle between 0 and 1. And then the next point is 45 degrees and 0.71. So 45 is in between 30 and 60, so it's going to be here. This is 45. So I go up. This point is 0.5, and this is 0.75. So the 0.71 is going to be approximately somewhere around here. So this is the approximate point for 45 and 0.71. And you can continue with the same points, and then what you get a graph which looks like the one which is shown. So, I mean, you can connect the points if you want, and you're going to get, wow, that was good. Now let's answer the following questions based on the graph. The first one, Jaskaran, what is the amplitude here?
1.
1. The amplitude is 1. How do we know it's 1? The maximum of the graph is 1. The minimum of the graph is -1. So 1 minus 1 is 1 plus 1, which is 2 divided by 2 is 1. So we know the amplitude is 1. Okay? Now, what is the period? Yes, sir. What is the period?
2.
What is the period? 360. 360. Now, the period I can write as 360 degrees, or I can write it as 2 pi. Remember I told you yesterday, pi is the radian representation of the angle. In this representation, pi is 180 degrees, 2 pi is 360. So 90 degrees is pi over 2. Okay? So the period is 360 degrees or 2 pi. Either case is correct. Now, the next question is asking is, what are, I'm sure, x-intercepts? What are the x-intercepts here? Okay, so the x-intercepts are 0, 180, 360. Only 3 of them because the domain is set to be between 0 and 360. But in general, for a sine function, the x-intercepts are 180 times n. N, it can be any integer, 0, 1, 2, 3, or -1, -2, -3. These represent the x-intercepts. Now, what is the minimum value for a sine function? What is the minimum value for a sine function? So the minimum value is -1, and it happens at 270 degrees. Can somebody tell me what is the radian representation of 270 degrees? Yes, Halina.
3 pi divided by 2.
Excellent. The answer is 3 pi divided by 2. Now, what are the maximum values, or what is the maximum value of the function? What is the maximum value? Yes, Amanda.
1.
And when does it happen?
90.
90. What is the radian one? How do you represent it in terms of pi? Yes, Jan.
Pi?
Sorry?
No.
No. Pi is 180.
Pi divided by 2.
Pi divided by 2. So the answer is 1, and it's 90 degrees, or pi over 2. Now, this is the interesting part now. The question is that what is the increasing interval? I hope everybody remembers this one from the first unit. The increasing interval, meaning when x goes up or increasing, y increases, or when x goes down, y decreases too. As long as they go in the same direction, then it means that the function is increasing. If they go in opposite direction, then the function is decreasing. Shalak, when is it increasing?
From 0 to 90 and from 270 to 360.
Excellent. So we say that x less than pi over 2 to 0, and x less than 2 pi to 3 pi over 2. Now, I prefer to use the radian. This is the most common way of writing angles. I mean, writing in degrees really is not that much popular. So, the question is that why are these two intervals are increasing? Let me just show you on the graph here. If you look at the graph and you walk from left to right, remember, always walk from left to right. If I walk along the graph, okay? If I walk along the graph and go up the graph, you can see that x is increasing from left to the maximum point, and also y is increasing. So I can say from 0 to 90 degrees, or 0 to pi over 2, the function is increasing. Now, if I continue walking, you can see that x is increasing, but y is decreasing. So this means the function is decreasing. So this is not the answer. But when I get to minimum -1 and I continue walking, x is increasing, y is also increasing, so the function is increasing. So between 0 and pi over 2 and 3 pi over 2 and 2 pi, the function is increasing. Now it's going to answer the second part, which is which interval the function is decreasing. And you can see that from 90 degrees, or pi over 2, to 3 pi over 2, which is 270 degrees, the function is decreasing. So let me write the decreasing intervals. We said the decreasing interval is when x is between 3 pi over 2 and pi over 2. Now, the next question, what is the domain of the function? Meaning, what are the valid values for x? Helena?
X in our 0 is greater than, 0 is,
Yep.
0 is greater than or equal to x and less than or equal to 60.
So x is less than or equal to 2 pi and greater than or equal to 0. Again, I would prefer to use the pi notation. Okay, so get used to it, 2 pi. Now, the next question says, what is the range, V?
Cannot the domain, the x values keep on going after? Yeah, but in this
No, but remember the question. The question says plot the graph between 0 and 360. So it's already constrained between those. You're right. The sine function can go from negative infinity to plus infinity, but the constraint says between 0 and 360. Now, what is the range? Amanda.
-1 greater than y.
So y has to be a member of R, and y less than or equal to?
It has to be greater than -1 and then less than 1.
Yes. So y is between 1 and -1 and is also a real number. Okay, for the second function, for y equal cos x, we are going to do exactly the same thing as we did before. We are going to find the exact ratio and then the rounded one. We know that cos 0 is 1, the decimal is 1, cos 30 is square root of 3 over 2, and then the decimal is 0.87, and so forth for 45 to 360. Now the only thing is that when you go over 90, you should use the unit circle to find the reference angle, and then from there you can find the cosine of the given angle. Give you one example, for instance, 120. To find the cos, you draw the unit circle. I know that it's 120, so this angle is 120. This angle is going to be 60. So the reference angle is going to be 60 degrees. Now we know that cos is the x-coordinate of the point, and 120 falls in the second quadrant, and in the second quadrant the x values are negative, so we know that cos is negative, and the reference is 60, so cos 60 is going to be 1 over 2, but it is negative because of second quadrant, so it's negative 1 over 2. So the answer is negative 1 over 2 and negative 0.5. And you can find the other angles exactly the same way. Having the angles and the decimal value, now to plot the graph, we are going to use the table of values we just found. And then, as before, I'm going to divide the y-coordinate 4 boxes to be 1 unit. So the middle one is going to be 0.5, which is going to be here. And then the same if we go down for negative values. And then I'm going to divide the points, every box to be 30 degrees. So it's going to be 30, 60, 90, and so forth to 360 degrees. Then it's just a matter of plotting the points. For instance, if we go to the first point, is going to be 0, 0. So the point is going to be right around. The first one, I'm sorry, is angle 0, is exact value is 1. So the first point is going to be here because the x value is 0, 0 degrees, and the angle is, the y value is 1. Then we are going to check the next one. The next one is 30 degrees is 0.87. 30 degrees is here. We go up 0.87. This is 0.75, so 0.87 approximately here. Then plot the other points as it's given in the table of values as I have shown here. And then you can connect all the points with a smooth graph curve, and you get, a cosine function which is shown here. But this cosine, remember, is between 0 and 360 degrees. Now let's answer the same type of questions as before. The first question, what is the amplitude here?
1.
The amplitude is 1 because maximum is 1, negative 1 is minimum, so 1 minus 1 is 2 divided by 2 is 1. So the amplitude is 1. What is the period? 360 degrees or 2 pi. Now the next question says, what are the x-intercepts? If you look at the graph, what are the points that the graph crosses the x-axis? You can see that the points are 90 degrees and 270 degrees. So I can say that the x-intercepts are pi over 2 and 3 pi over 2. Now, can somebody think of a formula, okay, in general to find the x-intercept is in a cosine function? So I can write in general, if there is no constraint on the domain, I can write the x-intercepts are 2n plus 1 times pi over 2. N can be any integer, positive or negative. Okay, now the next question. What are or what is the maximum value of the function? Oh no, minimum value of the function.
-1.
Negative 1, and when does it happen?
180.
Pi. Now, what do you think is going to happen to the general formula if I continue with the domain from negative infinity to infinity? What do you think is the formula for the minimum value of cosine? What do you think is the next minimum of cosine if I draw it?
540.
Sorry?
540.
The first one is at pi. Okay? Where is the next one, you think? If you plot it?
2 pi.
No, 3 pi.
2 pi?
3 pi. Over 2.
3 pi. What is cos of 3 pi? Can you use your calculator and tell me what is cos of 3 pi?
-1.
-1. What is the next one after this guy?
So is it 2n plus 1 time?
Yeah.
2n plus 1 times pi. So that's the general formula for the minimum values of a cosine function. Okay? So 2n plus 1 times pi. I hope you understand what goes on. It's very simple. Now, what is the maximum value? 1. When does it happen?
0 and pi.
0 and 2 pi?
Yeah, 2 pi.
2 pi. Okay. Now, start thinking of the next maximum value. When does the next one occur, you think?
540.
No, give me in terms of pi.
4 pi.
4 pi. What is the next one?
8
6 pi. What is the next one?
8 pi.
Now, start from 0. What is the one before it? Negative 2 pi. Next one before it? Now, what is the general formula? you think?
2 pi. 2 times pi. 2n pi.
Do you get it? Because the numbers are all even numbers. How do you get an even number? 2n. It doesn't matter n, what the value of n is. It always gives you an even number. Give n 3, 2 times 3 gives you 6, even number. Give n negative number, negative 5, it gives you negative 10. So the answer is 2n pi. Now let's go back to the graph and see the increasing intervals. So the graph is here. Can somebody tell me when the graph of y equal cos x is increasing? Shalak. From pi to 2 pi. So he is saying from this point to this point, the graph is increasing, and the reason is that if I walk on the graph from left to right, as I go up the graph, my y value as well as x values are increasing. So this means the function is increasing. And when is it decreasing? From 0 to pi. Excellent. So let's write it down here. So I'm going to have increasing is pi to 2 pi. And decreasing is 0 to pi. Now, what is the domain of the function?
The same as the sine function.
Excellent, the same as the sine function. So I'm going to write x in R and x less than or equal to 2 pi greater than or equal to 0. What is the range?
The same as the sine.
The same, y in R and y less than or equal to 1 greater than or equal to negative 1. And that's the end of the second example. Okay, the first question. without graphing, so no graphing involved, so stop graphing it. Determine the values of x for which the graph of sine x and cos x will intersect in the interval of 0 to 360 or 0 to 2 pi. Verify your solution by graphing, by solving the equation sine x is equal to cos x. So go ahead, I give you a few. Okay, so the first question, without graphing, find the values that satisfies or makes y equal sine x and y equal cos x to intersect at the same point between 0 and 360. Verify the solution by graphing, by solving the equation. Now, to find the x values, I'm going to try to solve it first. So I'm going to say sine x is equal to cos x. I'm going to divide both sides by cos x. This one goes with this one, so I get 1. And this one is tan x is equal to 1. I know by heart that x equal to 45 degrees is going to give me the first answer. But since the domain is 0 and 360, and this is my unit circle, and this is the reference angle 45, I have to find another angle in the unit circle, which is going to have tan x equal to 1. Now, if I go to the third quadrant, cos and sine, they have different sign. So sine divided by cos is going to give me a positive number. So if I reflect this point about the origin, I'm going to get another point here. This angle is equal to this angle, which is 45. So I'm going to say the next angle is 180 plus 45, which is 225 degrees. Now, these are the two solutions. Verify your solution. I'm going to plug in 45 and 225, and you can see using calculator that both of them, they give you 0.70, they give you 1, both of them. But for sine and cos, they give you the same answer. That's the whole point. By graphing is just use any graphing technology, your calculator, or go to Desmos, and then plot the graphs. Then you will see that they are going to intercept, at the same point. And those 2 points are going to be x equal to 45 degrees and x equal to 225. And by solving, I just solved it in front of you. Now, one thing I have to explain to you is that the answers that you got is 45 degrees and 225. When you use a technology like Desmos and you go and do it on the Desmos, I am sure you're going to have problem because what you see on the x-axis, they are going to be numbers like 1, 0.8, 0.7, and you may be surprised, how can I relate 45 degrees to the number which I see on the x-axis? Remember, the values you see on the x-axis are all the radian angles. So if you see on Desmos, it says pi over 4, okay? Can somebody divide pi by 4 and tell me what the answer is? Yes? No. Pi as 3.14 now in radian. 0.78. This means that on the x-axis you will see 0.78 represents 45 degrees. So do not expect to see 45 degrees on the x-axis. Everything is going to be in radian. And radian is, as you know, pi divided by 4 or pi divided by 2. So make sure you notice this one. Otherwise, you're going to be confused. Why my answer is different from what I see on the site.